Hello, my name's Alex Vasquez, and thank you for joining me. Today we're going to be focusing on another tech topic. Again, my goal is to help you be successful in technology, and in this field, there's no more important topic than understanding what a server operating system is. There's lots of different technology bits. There's hardware, software. You may know of a lot of operating systems that you deal with, right, on a regular basis. Right now, you could be on an Android operating system or iOS operating system, or perhaps Windows or even Mac, right? But when you start breaking down a lot of this, it's important to understand the differences between an end user operating system and a server operating system. So let's go ahead and dive in. And as we do so, keep in mind, if you have questions, feel free to put those in the comments. I'll go ahead and I'll be monitoring those this evening as well. All right. So what is a operating system? So let's break it down first, because I already mentioned a few. The first thing to understand is you have hardware, right? And hardware requires software in order for that hardware to be anything useful for you, right? Now, I'm not getting into ultra technical terms here. I'm just trying to keep it rather simple. But ideally is you have software that sits on top of your laptop, your phone, your desktop hardware, right? And that first piece of software that usually goes on is a operating system. Now, an operating system is designed to help pull all those hardware pieces together into a cohesive fashion and give you a way to be able to leverage that hardware and to run the different applications and tools and web browsers and play your video or video and games even. All of that is required. And so an operating system is sort of that base layer that is needed. And really, when you start thinking about an operating system, it's what allows the computer to function, and it more importantly allows you to interact with it, right? A lot of times, you're either tapping on your device, or maybe there's facial recognition, voice recognition, or you're using a keyboard and mouse or a different type of input device. Really, the understanding is that operating system takes those inputs, understands how to leverage them, and be able to give you a way to actually enjoy and use that computer as a tool, right? Now, I already mentioned a couple examples, but let's get into the differences a little bit when we're talking about end user operating systems versus server operating systems, because there is a difference. And when you look at those differences, I will say that you'll first be able to distinguish the differences in regards to what hardware is the operating system running on, right? Is it running on your computer, your laptop? Is it running on your tablet? Is it running on your television? Is it running on your Xbox or PlayStation? All of these pieces really identify that the operating system runs on personal computers, right? Now, a server operating system, a lot of times, yes, it could probably run on most of these things, but that's usually where it does run. It's installed on servers or specialized hardware that is used to manage network resources, multiple user environments, and to be able to store data from multiple people, right? Or maybe you have a storage device at home that is connected to your router or a network attached storage, but somewhere maybe you can store your pictures, your files. That device, whether it's a SAN or NAS, also has a operating system on it. But fundamentally, because any operating system can really be used for both these purposes. Now, you could specialize, but for the most part, it can be used that way. But the difference is that unlike an end user computer, an operating system, where you log into it, right, or it automatically comes on, it's your user profile, and you start running multiple applications all at the same time, or multiple applications, and the applications are only on or left on while you're logged into the device. A server has applications that will run when no one is logged into the device, right? And those devices and those applications really are what kind of starts distinguishing the difference between these two types of operating systems. Applications for the most part will run all the time for lots of people. And that makes it very purpose-built, so to speak, in regards to why you would have a server OS than just a regular operating system where everyone can log into it at the same time and be able to do stuff. Instead, end user operating system is those applications tend to only run when you're using the device. Okay. The other thing is that realizing a little bit in regards to applications is that applications on a server operating system, typically you don't run numerous applications on the same operating system. Okay. And there's a reason for that. We'll get into that here in a little bit. But for the most part, every server tends to be purpose built, right? It has a specific set of hardware, it has a specific operating system, and then it will run a few applications on it all the time and serve a few roles. Whereas, on an end user computer, you would typically log in and you'd launch all your applications on it, right? Whether it's, video, browsers, word processors, spreadsheets, all of that running on the same computer is on an end user. A server operating system takes the other approach. It would be as if you took Word, Microsoft Word, for example, and you just ran that on one server operating system. Then you took your web browser and you ran that on a different server operating system. And then you take those spreadsheets and you run that on a third operating system, right? Each one being purpose built for that application is really what I want to make sure you understand. And the reason for that is because we want to make sure that each one continues to be stable and is flexible and supportable. That way, if one of them goes down, it doesn't take down the others, right? So as you start dealing with the server operating system, and more importantly, the server management world, it's important to understand why a server is so different and treated so different versus like an end user operating system, okay? Now, as we dive a little bit deeper, let's focus in a little bit and highlight some of the other differences of an end user operating system. Because, when you think of an end user operating system, it's important to understand the differences. And the big things that are some of the ones that I've already mentioned. For example, an end user operating system, again, is designed more for either personal or business use, but it's designed usually to be used by a single individual, or in cases of like, let's say a hospital system, maybe there's one computer that multiple people log in, but they're only logged in one at a time, right? So it's kind of a one for one from that perspective. And then there's different operating systems: Windows 10, Mac OS, even Linux has, you can use Linux as an end user operating system, Android, iOS. But again, and then the visuals of it are really designed for non-technical users. This is where you can run all your typical applications, right? Microsoft Office, Photoshop, web browsers, et cetera, et cetera. And, some examples of these you're probably familiar with, whether it is, the Mac operating system with its operating system, it's OS 10 or OS X, depending on, I think X is now becoming the new standard of the world, but OS 10 is usually how I've always referred to it. These are what you would normally see, these operating system. Windows 11, you have Chrome OS on Chromebooks, and then you have iOS on Android, on Apple rather, and then you have Android on Google devices or any Android mobile. And so you can kind of see then that there's a slew amount of devices that all have some sort of operating system on. Now, as we start getting into the server operating systems, again, these are designed to help manage, store, and deliver really data to other computers on a network. Now that network could be over the internet, right? In the case of maybe you're opening up a web browser and you're going to your Gmail or your Outlook account, wherever you're grabbing mail from, those are running on servers and those are connected to the internet. And when you open up a browser, really what's happening is data is being sent from that server to your device, right? And it serves multiple people. And serves is why we call it a server. Because basically this device with this operating system is serving people, serving devices with data that it has. And it's either grabbing data, thus storing it, and processing it and handing it to other servers that have a different role of what to do with that data, or it's presenting that back to you or your browser, right? So that's just a few examples and not all inclusive. But I hope you start seeing and understanding the differences. Now, in addition to that, common operating systems are Windows Server, by Microsoft, Ubuntu Server, Red Hat. These are different flavors of Linux, CentOS. There's also Solaris, there's Unix, still out there, BSD. If you're a BSD fanatic, there's a couple of them out there. And then, Mac OS actually used to have a server flavor. I have to look back to see if they have, but I know they may be making some tweaks there. But really the understanding and the differences is in the user interface on a server, because it's really designed to try to minimize a lot of the glitz and glare that you see from a end user operating system, which is designed to attract you to it. Instead, a server operating system is more built around function, right, rather than form. And so, there may be minimal or maybe there is no graphical interface. Maybe there is. But oftentimes servers are managed remotely, and there's a practical reason for that. If you think back to what I mentioned about, the illustration of, maybe you have 3 servers, one with Word, Excel, and a browser on each one. They're purpose built. So I would want to manage all 3 of those in a very simple way, but I don't want to have to log into them just to do management, right? So a lot of times that management comes in remote tools. And so there's a whole management layer, which we'll get to in future lessons about different ways to manage, a server environment. But, I hope you start getting the picture. A lot of these are, pieces of the puzzle that come together and are managed in such a way that give you that flexibility. And when you look at why a server, what kind of roles does it have? Well, it could be a network server. It can be for a file server. It can be a storage server, web hosting. It could be a security server, like a monitoring type of appliance. It could be a backup server, and the list goes on and on and on. I mean, there's so many things that you can, their servers are designed and crafted for. Fundamentally, a server is pointless unless there's an application that is being used, right? And it's the application that ultimately determines what operating system you use, as well as why you would even use a server operating system to begin with. Okay. Now, when you start thinking again of those graphical interfaces, oftentimes a server, yes, it can look just like a desktop, and you can install it on a laptop. It really doesn't care from that perspective. But typically the hardware that's designed for our server operating system is designed and tested with much more resilient characteristics, a lot more error checking. A server operating system typically runs 24/7, 365 for years on end, right? And so as such, you want to make sure that it doesn't die just because one hard drive on it dies, or it doesn't go down because one power supply on it dies. Instead, it has built-in redundancy, and you pay for that redundancy when you're buying a server. But on an operating system level, you have Windows Server OS. You have that can be both a full GUI rather, as well as maybe it's a server core version, which is only graphical interfaces. Then you have Linux that, is very much text-based, and same thing, right? It's more command line management, whether it's on the physical box or remotely. Additionally, there's remote management tools, and here's a couple examples of Windows Admin Center, as well as VMware vSphere Web Client, right? All these are designed to manage multiple servers, whether the servers are physical or virtual. Now, I won't get into much virtual, at least on this conversation, but stay tuned for future sessions where we talk about what is virtualization. But the idea here is to be able to manage numerous servers, all within a simplified interface that allows you as an administrator to be able to control each of those and not have to physically walk up to every single server with its own keyboard, mouse, and monitor, but rather be able to access those things remotely. All right. And again, just recapping some of the differences. An end user operating system, very graphical, tends to be single user, limited resources. Whereas a server OS oftentimes is a command line. It's multi-user. It has enhanced network security, extensive resource handling, and so on and so forth, right? There's different purposes. Fundamentally, the purpose is going to be driven again by the application and what you're trying to do with it. Okay. Now, key items that are important for you to understand when you're choosing an operating system, so I identify these as key to a good operating system, is first, it has to be reliable. It's known that not every operating system is created alike. You have Unix and Linux servers that have been running for decades at this point, that still continue to run. You have to choose the operating system that is going to be the most reliable based off the manageability and the software that's being used. So example is, again, the whole point of an operating system is to service and to serve data and thus the application. So the application is the most important part of this equation. And the application is what determines what operating system will allow you to run it on. And when you're doing that, you then determine, what's the best choice of operating system based off the software requirements. You want to make sure that a server can be managed very efficiently remotely, because when you're dealing with 1 to maybe 5 servers, maybe you don't need a full management structure. Once you start getting to 20, 30, 100, 1,000 servers, yeah, you need to know that you can manage all those servers in such a way that you don't have to be overwhelmed or overburdened as a result of that. We already mentioned software. The next thing is secure. It has to be secure. There has to be regular supportability, regular patches, regular tools for antivirus and detection. It has to be supported by the masses and by companies to make sure that it doesn't become a liability or it doesn't become a spreader of viruses and Trojans and lots of malware. We've heard of ransomware. We want to make sure that it's as secure as possible and it can be managed properly in order to ensure that that doesn't become more of a burden and a liability versus an asset. Okay. So making sure that it's always the latest version. It's you're keeping your operating systems up to date. That means you have to have support contracts in place, making sure that the vendor, whether it's Microsoft or the Linux partner, is constantly patching and updating. It has the right levels of firewalls that are protecting it. And all of that has to be is part of the role of a good server operating system to give you those options. Also has to be scalable. I mentioned the 3 server scenario. Well, yes, you can run on one particular, all those applications on one server. But, when you start thinking about trying to build in reliability requires you to look at operating systems and applications in a slightly different lens. You want to think of, okay, what's my single point of failure? And you want to reduce those. So that means maybe it's 2 servers serving the same application. And when you do that, we call that high availability, right? We're increasing the amount of servers servicing a single application to be able to handle either a massive load, like for instance, perhaps it's a commerce server serving up a website that's putting up a sale on Black Friday. You want it to be able to scale out because of all the influx of users that are going to come in all of a sudden, and you don't want that application to go down. That's just one example. So scalability is important, and as well as being able to condense that down after Black Friday, when, you know, instead of 1,000 users normally, you need to go back to your normal 20 or 30, right? The other is cost, because, you know, there are operating systems that do have a significant cost, but they're purpose built for that reason. Others may be free, right? But sometimes you have to be cautious because you get what you pay for, right? Not that those operating systems may not be good, but they may require a lot more management than you're prepared for, or, you know, they just may be purpose built for a specific reason and not give you the scalability as well as the multi-purpose capability that you may need. So cost will vary heavily between them. So just weigh that when you're trying to choose an operating system as well. All right. So, you know, that pretty much concludes this session for what is a server operating system. If you want more, I encourage you to join us every Tuesday at 8 p.m. Eastern live. And as such, we also encourage you to join our Facebook group, Expert Hats Tech Training Center. We'll put the links in the comments, as well as you might see something here pop up in a minute, as well as, you know, if you want to learn how to install VMware Workstation to start building out your lab, I have a video available within our Facebook group that you can go in our Facebook group and be able to get access to that, where I walk you through installing the new VMware Workstation and building out the foundation for your lab, right? Whether it's a server operating system or Windows 11 virtual machines, you know, starting to learn and get your hands on it, understanding the differences will be very important into your tech career, and to help you get, more important, that hands-on experience that you need when you're trying to get into a job, a tech job of any kind. Okay. Also, that, you know, as you access this, I provide a free case study on how to earn 6 figures if you are coming into the tech field. So, you know, links will be provided within our Facebook group as well. So I encourage you to reach out and keep putting those comments in the chat, and I'll be answering those here as I go along. All right. Well, thank you very much, everyone, for your time for this live. And so I appreciate everything, and, you know, thank you for watching. Take care.